Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied that what is enthalpy, what is entropy and what are the state functions of them. That is what is showing a state function and which one is showing a path function. So now we are going to exclusively talk about what is enthalpy of the physical state. So what is this? Let us talk about it. So now starting with the enthalpies of physical state. As you know, the enthalpies of physical state means we are going to deal with what will happen if a solid will convert into liquid, or a liquid will convert into a gas, as well as the solid will convert directly into gas. So this kind of basically physical states that we are going to talk about. So let's start talk with the first one, that is enthalpy of fusion. So what does enthalpy of fusion means? It means the enthalpy change that accompanies the fusion of 1 mole of a solid without change in temperature at constant pressure is called as enthalpy of fusion. So, and yes, it is denoted by delta H of fusion. So this fusion, that is, I have written in FUS, that should be in the subscript below the delta. So what does actually the enthalpy of fusion means? The fusion is nothing but the conversion of a solid substance, which or a substance which is in a solid phase to a liquid phase. That kind of transformation is basically known as fusion. So therefore, in this case, what we are going to do is we are going to check, or we are analyzing that what is the enthalpy change that takes place when a solid phase of a substance is being converted to its liquid phase. But the conditions are that have been mentioned in this case is, yes, it should be at constant temperature and at constant pressure. So at constant temperature and at constant pressure, the change that we could observe from a transition from a solid phase to a liquid phase is basically known as the enthalpy of fusion. So for that we have example. So let us talk about that also. So this is an example of the enthalpy of fusion, in which you could see that H2O, which is in a solid state, which is nothing but ice. So if we have to convert into other state, but the thing is the chemical composition remains the constant. And in this case, as we could see that the substance, that is H2O, is been converted into liquid H2O, which is nothing but we are making it fuse. We are making a process of fusion. So in this process, what happens is the delta H, or the change in enthalpy during conversion of a 1 mole of a substance which is in a solid state to 1 mole of a substance which is present in a liquid state. So that during that kind of process, what will be the change of enthalpy, that will be known as enthalpy of fusion, and in this case it has been found to be plus 6.01 kilojoule per mole, but yes, at 0 degrees Celsius. The temperature that has been maintained here is 0 degrees Celsius, and we know that at 0 degrees Celsius the water freezes. And if we have to convert a solid into liquid for a particular water, suppose if an example, if I would say, so what is the thing that we should provide? We should increase the temperature. So above the temperature of 0 degrees Celsius, the ice will start to melt. And it will start to melt and it will convert into liquid. But in this case, what we have done is we have maintained the temperature to be constant, that is 0 degrees Celsius. And in that case, we are providing a kind of energy. So that kind of energy will leads to the conversion of the solid to the liquid at the same temperature as well as at the same pressure. So for that instance, I have given a statement in this case, so it would be very much easy to understand. That is, this equation indicates that when 1 mole of an ice melt at 0 degrees Celsius and at 1 atmosphere pressure, the change in the enthalpy is 6.01 kilojoule. So this is the change in enthalpy that we observe. But yes, one thing that we should know, that we have written here plus 6.01. This implies that we have to provide energy to the phase, that is to the H2O solid phase, so that at 0 degrees Celsius it will convert into the liquid phase of H2O. So this plus 6.01 is nothing but the heat required to convert the H2 which is in solid phase to H2 which is now in a liquid phase. So this was about the first physical transformation, that is nothing but the heat of fusion, or known as enthalpy of fusion. So now let us talk about the another one. But before talking about the another one, so in this case, let me tell you another example related to this thing. Suppose what will happen if I will convert the liquid into solid. So this kind of process where I convert liquid into solid is nothing known as freezing. So the change, the enthalpy change that I will observe or during this comparison from a conversion of a 1 mole of a liquid to 1 mole of a solid of that particular substance, the thing that will happen is we are going to freeze it. So that's the reason the enthalpy of fusion now will be the enthalpy of freezing. So in this case, what will happen? The 6.01 energy that we have provided to the solid so as to convert it to a liquid. Now what we are going to do? Now this delta H of freezing will be minus 6.01. That implies that the energy has been lost, means we don't have to provide energy, the energy will lose if a liquid will convert into a solid. So that is nothing but the magnitude remain the same, that it will remain 6.01 kilojoule per mole, but the thing is the sign will change. The sign which was earlier positive, now it will be negative. So that is the change that we will observe. So this was the first transition, and in that only we have did what is enthalpy of fusion as well as what is enthalpy of freezing. So now let us talk about the another physical change that we could observe in the chemical reactions or in a phase transitions, that is enthalpy of vaporization. So what does enthalpy of vaporization means? So the enthalpy of change that accompanies the vaporization of 1 mole of a liquid to a gas basically without changing its temperature at constant pressure. So this means what? Or easily we could define this enthalpy of vaporization as this one, that the change in enthalpy observed during conversion of 1 mole of a liquid to 1 mole of its gaseous state at constant temperature and at constant pressure. So this is the simple statement that we could also make in consideration, as well as we could also consider this statement also so as to define what is enthalpy of vaporization. So it is denoted by delta H of vaporization, that is delta H, and in the subscript it is VAP, that is nothing but the vaporization process. So in that case, what happens, I will give an example so as to make you understand that what is actually enthalpy of vaporization and what would be the value of that. So this is the thing where the H2O which is present in the liquid state and we have to convert that into a gaseous state. So vaporization is nothing but the conversion of a liquid into a gaseous state. So in this case we have converted the H2O which is present in liquid state to its gaseous state, but the temperature has been remaining constant. We have kept the temperature to be constant, and in this case it is 25 degrees Celsius. But the heat of vaporization or the enthalpy of vaporization that we have observed in this case is plus 44.0 kilojoule per mole. So that means, suppose at 25 degrees Celsius, as we know that 25 degrees Celsius the water remains in a liquid state, but we don't have to convert that liquid into a gaseous state by increasing the temperature till 100 degrees Celsius, because 100 degrees Celsius is the temperature where water gets boiled and or water gets converted from liquid state to gaseous state. So what we are doing is we are maintaining the temperature to be constant, and at that temperature we have to convert the liquid water to its gaseous state. So it is only possible if we provide heat or if we provide energy to the system which is H2O of a liquid phase. So 44.0 kilojoule of energy is the amount of energy that is we should provide to the H2 which is present in the liquid state so as to convert that compound or that substance into the same substance but in a gaseous phase. So in this case we could see that plus 44.0 kilojoule of energy is being needed. So basically at 25 degrees Celsius we have to provide basically 44.0 kilojoule of energy to the liquid state of water. So what will happen, suppose if I have to increase the temperature, so suppose if I increase the temperature at 100 degrees Celsius, and in that case we have to maintain the temperature to be constant, and we have to see that what is the energy that we have to provide so as to convert the liquid state into a gaseous state. So in that case, what it has been found that the enthalpy that is now in this case, it is 44.0 kilojoule energy at 25 degrees Celsius. So at more temperature, means more than 25 degrees Celsius temperature, the enthalpy will be now reduced. So the value of at more than 25 degrees Celsius, suppose if I am talking about 100 degrees Celsius. So in this case, the enthalpy to provide it to the liquid phase will be very much less than that of the 44.0 kilojoule per mole, that kind of energy. So we have to provide less energy compared to that of this energy that we have at the same temperature or at a constant temperature of 25 degrees Celsius. So this was a thing which was based on the conversion of a liquid into gas. And in this case, we have got to know that the enthalpy that we should provide is basically 44, that we have got to know. But what happens if the process changes, or if the process reverse? Means I'm talking about what happens if the H2O, which is present in a gaseous state, and we have to convert that into a liquid state. And in this case, what kind of energy that we have to provide, or what will be the energy that we will lose? Let us talk about that also. Suppose if I'm talking about when H2O, which is present in a gaseous state, and I have to convert the H2O into H2 itself, but in a liquid state. So what will be the delta H? So let me give you a small reminder that you know already. That is the conversion of a gas to liquid is nothing known as condensation. So, and conversion of liquid to gas is nothing known as vaporization. So in this case, what will happen is we are going to condense the liquid water, basically H2O, which is in a vapor phase right now, and we are going to convert it back to the liquid state. So in this case, we are trying to condense it. So therefore, this would be, the enthalpy would be, the change in enthalpy would be delta H of condensation. And in this case, the energy that we have to provide or that will be removed will be depend on what? It will depend that it is transforming from which phase to which phase. So in this case, what happens is the gas has been transformed into liquid. So whenever a gas phase which has been transferred into a liquid, means energy will be lost from the system. That is, let me give an example of this thing. That is, obviously we know that if we have to convert a liquid phase into gaseous phase, that means we have to increase the temperature, or we could say that we have to provide the energy. So since we are providing the energy, but the energy is being provided to the system, that is, the energy will be provided to H2O, which is in a liquid phase, and from that only the H2O, which is now in a liquid phase, will now convert it into a gaseous phase. That's true. But in a reverse case, what happens is when a gaseous state is been now converted into a liquid phase, so now the reverse process will happen. We don't have to provide energy, the system will now provide energy to the surrounding. So that means, what I'm trying to say it as, we have provided earlier 44.0 kilojoule of energy to the system. So now what will happen is minus 44 kilojoule of energy or enthalpy will be lost from the system, and at same temperature, that is at 25 degrees Celsius. So at 25 degrees Celsius, I have kept the temperature to be constant, and at that temperature actually the energy is being lost from the system, or you could say during the conversion of a gaseous state of H2O to a liquid state of H2O, minus 44.0 kilojoule of energy is being released during that process. So this is nothing but the enthalpy of vaporization, as well as we have got to know that is what is the enthalpy of condensation. It will be the same, but the phase will be the different thing. So now let us talk about what would be the enthalpy of sublimation. That is the next phase that we are going to talk about here. Is this. So now let us talk about what is enthalpy of sublimation. So the enthalpy change that accompanies the conversion of 1 mole of a solid directly to its vapor phase at constant temperature and at constant pressure. So sublimation is nothing but we have to convert a basically solid into gas without forming a liquid phase. So that is nothing known as sublimation. Because yes, there are also a few compounds that we know that undergo sublimation process if provided more temperature to that, or a specific temperature to that, but they do not form a liquid phase during that transition. So this is what sublimation means. So sublimation is related to conversion of solid to gas directly. If we say that a solid is been converted into liquid, and that liquid is been converted into gas. So overall, in this process, what happens is we can see a liquid phase that is the intermediate between the transition of solid to gas. So in that case, we cannot say that the solid has been sublimized. Either we could say that solid has been fused and then it has vaporized. But when we are talking about what would be the sublimation process, so it means solid is converted into gas directly without forming a liquid phase. So that is the difference between those two. And yes, and talking about this thing, so enthalpy of sublimation is nothing but delta H subscript, that is sublimation. So this is nothing but the energy that would change, or the change in energy that we would observe if a solid has been converted into a gaseous phase. So for that example, let me give you a short example for that. So this is the thing. So basically, here it is H2, which has been present in a solid state. And suppose if we have to convert this H2 directly to its gaseous state without forming a liquid state. So what will happen is and that too, the temperature has been set to be constant, that is 0 degrees Celsius, and the atmosphere is also 1 atmosphere. And in this case, what happens is we have to convert this solid into a gaseous state without forming a liquid state, but the energy will not be like the previous one that we have did, that is 44 kilojoule of energy in which liquid was been converted into a gaseous phase. We have to provide more energy, and that's the reason the delta H that we observe here is plus 51.08. So this much amount of kilojoule of energy that we have to provide out, this kind of change that we would observe during the conversion of solid to a gaseous state. So this is what sublimation means, and heat of sublimation or enthalpy of sublimation means. So this were the three kind of physical states or physical transition that we have observed, and the enthalpy is also during the physical transitions from that is solid to liquid, liquid to gas, as well as solid to gas. And between, we have also learned that is what would be the enthalpy if liquid is being converted into solid phase, as well as gas will be converted into liquid phase. So this where basically we have talked about enthalpies during the phase transition. But there are also some kind of enthalpies and some few definitions that we are going to talk about. So let us talk about that also. But this was basically enthalpy of physical transitions. So now let us move on towards the next kind of thing that we should understand this definition very clearly, because this definition will be very much helpful in the Born-Haber cycle process that we will do in the next lecture. So let us talk about that also. So this is enthalpy of ionization. As the name suggests, means the heat that is required or so as to convert a particular atom or into its ionic state. So let us read the definition and let us understand it. So enthalpy of ionization means the enthalpy change that accompanies the removal of an electron from each atom or ion in 1 mole of gaseous atoms or ions is called as ionization enthalpy or enthalpy of ionization. So what does this mean? The first thing that we should know that what is ionization. Ionization is nothing but the process of conversion of an atom to its ion, or so as to and this will only happen if we remove the electrons. And even though if we give electrons, that also will convert the atom into an ion. But in this case, what we are talking about is we have to remove the electron. So if we remove the electron from an atom, then only it will convert it into positive kind of ion that is known as a cation. And talking about the next thing, we could also remove a electron from an ion. That is, suppose if we have a cation, and from that also we could remove an electron. So in this case, we could also remove electrons from a cation. So if we remove 1 electron from a cation, that will lead to a oxidation of 2 charge on, or 2 positive charge on that kind of atom. Basically, if we'll remove an electron. So let's talk about this thing. So what does ionization means? It is a very easy concept to study. So enthalpy of ionization is basically denoted by delta H of ion. This ion is nothing but the ionization. And let us talk about this thing, that what we have talked earlier during these examples of enthalpy of ionization. So this is the thing that I have talked about. Suppose what happens if this is the calcium which has been present in a gaseous state, and in this gaseous state we have to remove an electron. So if we have removed one electron, so therefore this will acquire a positive charge on the calcium. So therefore in this case what happens is, if we have to remove the electron, so 590 kilojoule of energy is being required so as to remove the electron from the calcium which is now present in a gaseous state. So in this case, one electron has been removed from the calcium, and since now we have converted an atom into its ion, so the change in enthalpy that occurred during this transition or this process now will be 590 kilojoule of energy or enthalpy. So this was the first thing that I was talking about, when what happens when we have removed an electron from an atom. So this kind of energy that we have to provide, or the change in energy that we observe during a conversion of an atom to its ion by removal of one electron, is nothing known as ionization of enthalpy or ionization enthalpy. So talking about the next one, even I have said that suppose we can also remove electrons from the cation also. So in this case Ca plus, that is the calcium plus ions which is again present in the gaseous state, and in this case we have to remove another electron. So if I have removed electron, as you could see, if I have removed electron in this process, then this calcium will acquire 2 positive charge, or the oxidation number of this calcium will now be 2 plus. So again this is again present in a gaseous state, but the energy required to remove this electron from calcium plus ion will now be basically 1150 kilojoule per mole. So this indicates what? Let me give you a short brief analysis about the thing that we have observed. This what and why do we observe this drastic change? That is, to remove one electron from a atom, it requires 590 kilojoule, but to remove another electron from an ion, it requires more than that, while that of 1150 kilojoule of energy. So basically this is known as first ionization enthalpy and second ionization enthalpy. So what does first ionization enthalpy and second ionization enthalpy means? So in this case, as we could see, we have removed one electron from this atom, that is calcium atom, which is present in a gaseous state. So the energy that has been required to remove the electron from an atom to lose one electron and to form an ion is known as ionization enthalpy. But that ionization enthalpy will be the first ionization enthalpy. And now, what happens if we have to remove the electron from the product that we have got from the first step? Suppose in this case we have got calcium plus, and suppose if we have to remove electron from the calcium plus so as to make calcium 2 plus, having a basically 2 plus oxidation state. So the energy required will be more than that of the earlier one. So this is the one known as second ionization enthalpy, and always second ionization enthalpy is always greater than that of the first ionization enthalpy. The reason behind that is, here as we could see that calcium is now been isolated with its electron, so therefore Ca plus is now been differently from that of its electron that it had. But if we have to remove again electron from the calcium plus, so what will happen is all the electrons that are present in the inner shells of the calcium will have a very strong force of attraction, or we could say electrostatic force of attraction, between the positive charge that it has acquired as well as the negative electrons that are present in the atom. So this will be a stronger force of attraction that will keep the calcium inner atoms, inner electrons to its positive charge that has been acquired by the calcium. So there will be very large force of attraction between them and huge force of attraction between them, and from that if we have to remove an electron, so we have to provide more energy. That's the reason second ionization enthalpy is always greater than the first ionization enthalpy, as you could see here. And there's a very drastic change that you could observe, that is, one is 590 while the other one is almost double than that of, if you could say, that is 1150. So it's almost 1.5 times more than that of the first ionization enthalpy. So this is what the ionization enthalpy or enthalpy of ionization means. It was very much simple. But let us talk about the another transition that we could observe in thermodynamic, and these are all are the basically properties of that. So let us talk about electron gain enthalpy. So the enthalpy change that we observe when 1 mole of a gas phase of atoms of an element accepts electron so as to form a gaseous anion. So this is basically, let me tell you about this thing so as to make clear that what is the difference between the electron gain enthalpy and ionization enthalpy that we have did in recently. So as I told you earlier also, that is ionization enthalpy is for to remove electrons from an atom or an ion to form a positive ion. So now in this case it is electron gain enthalpy. So electron gain enthalpy is somewhere where the atom of a particular element will accept electron. So during what happens is during this process, since the electron is been accepted by that atom, so now this atom will acquire a negative charge. So now this atom which acquires a negative charge is basically known as anion. So therefore, if electron is been accepted by the atom, so that means it is known as electron gain. The electron has been now gained by that atom. But the energy that has been released, or that has the change that we could observe, that kind of energy change is known as enthalpy of electron gain enthalpy, as we could say. So electron gain enthalpy is what they have denoted it, and for that we could also denote it by delta H is equals to Eg. This Eg stands for electron gain enthalpy. So let me talk about more description about this also. This is the reverse of that of the ionization enthalpy, because in ionization enthalpy and a cation is been formed, while in that case of in electron gain enthalpy always an anion is been forming, or during this process basically electron is been accepted by atoms or basically ions. So for that I have an example for you, so it would be very much easy to understand. The example is this one. In this case what we see is chlorine which is present in a gaseous state, and now as you could see it don't have any kind of charge present on it, or we could say that the oxidation number of this chlorine which is present in a gaseous state, this atom has no charge, so therefore the oxidation is 0. But what happens if it accepts electron? So this kind of acceptance of an electron by an atom is known as electron gained by the atom, and the change in enthalpy that we could observe by gaining the electron is known as electron gain enthalpy. So what will happen is this atom now will accept the electron, and now it will convert into Cl minus, which is nothing known as anion, because any atom which acquires a negative charge is basically known as anion. So in this process, as you could see, the change in enthalpy that we could observe is minus 349 kilojoule. Earlier what we have did all were basically what we have did in our physical transition enthalpy. So in that case we have to provide the energy, and that the reason the energy or the change in enthalpy that we have observed was positive, means that kind of positive energy we have to provide to the system. But now in this case what we are observing is we are observing minus 349. This shows that electron, during acceptance of an electron, energy is being released from the process or from the system. So in this case during acceptance of an electron, energy is being released, that is minus 349 energy is being released from the conversion of a gaseous chlorine atom to a gaseous chloride anion, or we could say in that manner also. So minus 349 is the energy that has been lost. So this is what the difference between the two that we have observed. But let us talk about the another one that we have. So since we are learning chemical thermodynamics, so in chemical thermodynamics there are various terms or change in enthalpy that we would observe. One among those is enthalpy of atomization. So this is known as enthalpy of atomization. So before understanding what is enthalpy of atomization, the first thing that we should know is what is atomization. Atomization is nothing but the process where we convert a particular molecule which has been present in a gaseous state to its individual atoms through which the molecule is being made up of. For example, suppose if I am talking about HCl, suppose if HCl is a gaseous molecule if we have, and if I am want to atomize it, so basically what we have to do, we have to convert that into an individual H atom, that is hydrogen atom, and a chlorine atom. So this kind of process where we have dissociated a particular molecule to its individual atoms from which it has been made up of is known as atomization. So now let us talk about what does enthalpy of atomization means. So the enthalpy change accompanying the dissociation of all the molecules in 1 mole of a gaseous phase substance into its gaseous atoms is called as enthalpy of atomization. So what does it tries to say it as? If we have 1 mole of a gaseous substance and if we have it will contain more number of molecules, gaseous molecules, and in that if all the molecules are being converted into its individual atoms from which the molecule is being made up of, that kind of process when we apply on 1 mole of a substance is known as enthalpy of atomization, which means we are converting the molecule into its individual atoms from which it is being made up of. So therefore that kind of enthalpy of atomization is now denoted by delta H atom. This atom is nothing but atomization process. So just as to make it clear, I have an example that I could show you. That is this one. So in this case, basically the Cl2 molecule, that is the chlorine molecule which is present in a gaseous state, and it is now being converted into Cl atom, which is again a gaseous state, and another Cl atom, which is again in a gaseous state. So this all processes are taking place in a gaseous state only. So in this process, as we could see, that the molecule is now being dissociated into its individual atom from which is it made up of. So therefore these are the chlorine atoms that has been formed because of the chlorine molecule from which we have provided the energy, or from on which we have did a particular process known as atomization. So in this process, basically the delta H atom, known as the enthalpy change of during atomization, is equals to 242 kilojoule per mole. So that means we have to provide 242 kilojoule of energy to 1 mole of a gaseous system or gaseous substance. In this case is Cl2, which is present in a gaseous state, so as to convert the Cl2 molecule into atoms. So this is nothing known as enthalpy of atomization. So we could consider any of the example, and this is an example where we have to spend, or where we need 242 kilojoule of energy, but different molecules, they will have different kind of enthalpy of atomization. So this one was a very crucial one that we had to know, because this all the thing that we have did today or we are doing today, it will be very much beneficial to understand the thermochemistry more and better. So talking about the next one also that we have now enthalpy of solution. So what does enthalpy of solution means? Simply telling about this thing, it would be the change in enthalpy that will occur when a particular substance has been dissolved in a particular quantity of liquid, and during that process what kind of enthalpy change would occur. That is nothing known as the enthalpy of solution. So let us talk it by reading the definition. So it is defined as the enthalpy change in process in which 1 mole of a substance is dissolved in a specific quantity of solvent so as to form a solution of a particular concentration at a given temperature or at a constant temperature is known as enthalpy of solution, and it is been denoted by delta H, and it has a subscript as SOL, that means solution. So what does it says? For an example, suppose if I have 1 mole of NaCl, that is common salt with me, and if I am dissolving in 1 liter of or 1 dm cube of water. So basically it is quite obvious to know that the NaCl will now easily dissolve in water, because it is a very soluble substance in water. And in that process, the enthalpy change that I observe when I have added 1 mole of a NaCl to 1 liter of water, liquid water. So that kind of change that I have observed when NaCl has formed a solution by dissolving it in water is known as enthalpy of solution. So this is the example that I have mentioned. So let me talk about that what amount of energy is required or it will release when this would happen. So this is the thing. So when 1 mole of NaCl is dissolved in water to form 1 molar solution, so in that case 4 kilojoule of heat is absorbed. So therefore the delta H of solution of NaCl in this case would be 4 kilojoule per mole. So that means 4 kilojoule of heat is been absorbed, or we could also say so as to dissolve NaCl in a liquid water to form a 1 molar solution. That means 1 molar of solution will only form if we have dissolved 1 mole of a liquid, 1 mole of a NaCl in 1 liter of water. Then only 1 molar of solution will be formed. So during that process, basically 4 kilojoule of energy is being needed so as to dissolve the NaCl. So that means this is the enthalpy change that we observe when NaCl is been dissolved in water. So therefore we could clearly indicate, say that 4 joule of energy is been absorbed during that process, or we could say that 4 kilojoule of energy is being needed so as to form 1 molar solution of NaCl. So this was what we have talked about the enthalpy of solution. So now let us move on towards the next one that we have. Now we are going to talk about what is crystal lattice enthalpy. So let me tell you, enthalpy, when it is related to crystal, means crystal is only the form where we could easily observe in an ionic compounds like NaCl and CaCl. So these are the compounds which are basically crystalline solids. So this kind of the arrangement of crystal which have, or the energy required to form a crystal, that kind of energy is nothing known as crystal lattice enthalpy. But let us learn more when we will do the definition of it. So the enthalpy change accompanying the formation of 1 mole of formula units of crystalline solid from its constituent ions in a gaseous state is known as crystal lattice enthalpy. That is what we have talked about. Suppose if we have to form NaCl, which is an ionic compound, but as you know that NaCl will only be formed when we have introduced sodium as well as chlorine atoms. So in this case, what happens is if we have introduced Na, that is sodium atom, as well as chloride atom, so what will happen is they will come close to each other, and that kind of energy that is required to us so as to form the NaCl as a crystal will be said to be crystal lattice enthalpy of that particular compound, basically of that substance like NaCl. So for that we have an example related to that so as we could understand better. So suppose if we have a kind of cation that we have, suppose I have named it as M plus, and usually this cation will be positive so as to make a ionic solid, ionic compound which is basically in a solid state when it is in a crystal format. So this M plus, which is present in a gaseous state, plus X minus, this X minus will be a non-metal, or usually we describe it as a anion. So therefore when a cation and anion, when the both comes towards each other so as to form a compound or so as to form a molecule, in this case what we observe is that M plus plus X minus will give Mx, and that will be a crystalline solid of an ionic compound which is in a solid phase. So in this case what we observe is that the delta H, or the crystalline lattice enthalpy, is negative. So in this case what we clearly see that the crystalline lattice enthalpy that has been denoted by delta H of L that we observe here, so it is negative. So this shows that whenever the two ions or the constituent atoms so as to form a particular molecule, if they come towards each other or during the formation of that process, basically the enthalpy is been released. So this much amount of energy which has now been a negative, which has a magnitude of negative thing, now it will be released during this process. So that's the reason they have a negative value. While suppose if we have inverse the process, that means suppose if we have converted the solid that we have, crystalline solid that we have, and if we are converting into individual atoms or ions that we have, like M plus and X minus. So in this case, the delta H of L that we have will be positive. So therefore this is very similar that we have did today itself. That is nothing but the enthalpy of atomization. So this is the molecule that we have, and now we are going to distribute it, or now we are going to dissociate it into its individual atom. But as you could see, they have positive charge and they have negative charge. And but if it has if we had converted into an individual atoms like M and X, this would have been considered to be the enthalpy of atomization. So it is very much similar. And as we know that energy has been needed during conversion of a molecule into its individual atoms. So in this case, similarly, the delta H, that is the crystalline lattice enthalpy, is positive. That means energy is being needed, or energy is required so as to convert this solid into this product. So this is what the enthalpy of crystalline lattice means, and it plays a very vital role in understanding a particular substance, that how much energy is being released or how much energy is being required so as we could give to that particular substance, and so as to dissociate it. So this is plays a very important role to understand a particular substance, and different substance will have a different crystalline lattice enthalpy, because there are metals also, there are ionic compounds also, that they have a very strong force of attraction when they are present in a cation and in an anionic form. So it is very much important to understand that concept. So now let us talk about the another one, that is enthalpy of hydration. So it is very much simple to understand. That is, hydration is nothing but the process in which an individual atom or ion is been surrounded by the water molecules when it has been dissolved in water. Suppose if I have consider suppose NaCl, the same thing that I'm talking about, or NaOH, or any kind of substance that has been dissolved in water. So what will happen? A particular individual cation now will be surrounded by the water molecules, while the other atom or the other ion will also be surrounded by water molecules. So this kind of process, when an individual atom or ion is surrounded by the water molecule, is nothing known as hydration. And now when we are talking about enthalpy of hydration, it would mean that how many which amount of change that we could observe during that process, when we are talking about energy or enthalpy, that is nothing known as enthalpy of hydration. So the enthalpy of hydration is defined as the enthalpy change involved in hydration of 1 mole of a gaseous ion. So recently we have talked about hydration also, that is what is hydration which means, and it is been denoted by delta H of hydration. So for a simpler example, let me give you a few things so that you could understand better. So in this case, basically this is an cation, that is Mn plus. Now it has been dissolved in water, so it is quite obvious that we have discussed this earlier also, that if an atom has been dissolved in water, it will be surrounded by water molecules. So as you could see that this Mn plus, which is now in a gaseous state, when it has been dissolved in water, or when it has been interacted with water, so this M will be now surrounded by X H2 molecules. And as we could see, because this atom is now been surrounded by the H2 molecules, so because the two substance or the two things, they have collided with each other, or they have collaborated with each other. So in that process, what happens is the energy is now been released. So when we are talking about when M plus is now been collaborating with X minus, so whenever they come close to each other, or whenever they form Mx as a compound, suppose, so they will liberate energy, or that much amount of energy has been now liberated from that system or that process. So similarly here also we could see that the delta H of hydration that we observe here, that is the enthalpy of hydration, is here negative. So the energy has been released during this process, and similar to that of the another anion that it has. Suppose if this Mn plus was an cation and this X M minus is the anion, so again this would be interacted with water, and X moles will be now surrounded by H2 molecules. So, and again in this case the delta H of hydration will be negative. So this is what we have talked about. But talking about this thing, when we are talking about the enthalpy of solution. So whenever we add a particular substance in a particular amount of solvent, or we could say it as water, so what happens is the liquid get dissolved. So when the liquid get dissolves, there are two kind of energy that are been acting so as to form a solution. The first is basically the energy has been required to break the bonds between or to break the molecules of the solute or the substance that we have added in the water. So that is nothing known as the crystalline lattice that we have. And now here what we have learned is the hydration is also taking place in that process. So basically the last statement that I want to explain you is the delta H of solution, basically the change in enthalpy of solution, is equals to, or it will be accompanied by two processes, basically delta H of lattice or crystalline lattice plus dehydration, enthalpy change of hydration. I would write it here. So this is what a solution undergoes when or this kind of change that we observe when a particular substance is being dissolved in a liquid. So two kind of process that takes place. That is, the first process is to dissociate the two atoms or ions of a particular substance, and again now that ion or that substance now will be surrounded by the water molecules, or that will undergo hydration. So this is what I meant to explain. So this all were based on the enthalpies or the change in enthalpies that we have did in this lecture. So thank you friends for watching this video. I hope you have got a full understanding that what does this term, what kind of this term means actually. So share this video with your friends, and yes, I hope you have liked this video and you'll study this kind of concept more and more. Until, share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.